Welcome back to the course. Today we'll be looking into setting up some really simple collectible coins for our little alien to pick up so they can pay the rent. We'll be covering some really simple pick up and collect code with some global signals so we can actually make use of those coins in the future. Signals are an extremely powerful and versatile tool that can help us connect code without actually coupling it too heavily. Global signals are even stronger and will allow us to do some really insanely cool things. Now, what actually are signals? Right? I've just given you this whole thing about signals, but what are signals? Well, let's go and click on our player entity real quick. If I go into the inspector, you'll see there's 3 tabs here: inspector, node, and history. If I click on node, you'll see there's this button here for signals. If that is highlighted blue, which means it's selected, and I scroll down, you'll see that there are a bunch of signals, really. They're kind of just like functions, but they do something specific. Like this one, mouse entered. And it says here, emitted when the mouse pointer ends or enters any of this object's shapes. Basically, if I were to use this signal and then hover over the player, I could get it to print out something to the output down here. Same with mouse exiting, or mouse shape entered, mouse shape exited, specific input events. And you'll notice that every single object or node type we've inherited from has these signals as well, including the ready signal. Now, how are we going to make use of this for coins? Well, there's a few things that we're going to want to set up first. So let's go to our main level, and we're going to set up a new child node inside of this. This child node will just be a normal node. It doesn't need to be a node 2D, it can just be a normal node. I'm going to put this at the top here. I'm going to call this the manager container. So what is a manager container for? Well, we're going to be using this to hold any manager we create. And what managers will do are they will listen for a signal. They will take in any parameters from that signal, and then they'll do something based off of that. And they'll be kind of like a storage device for us. And that's going to be really useful to do quite a few things, like having collectibles, not just one, but hundreds, and having one thing listen to that and then build or affect certain things based off of those. So let's very quickly go and set up the manager container or manager itself. So what we're going to do is we're going to add a new scene. This is going to be of other node. It can just be of type node. It doesn't actually need to do really anything other than exist. We could just even make it a script by itself and instantiate the script, and it'll turn it into a node. But for now, we're going to call this the collectible manager. So we've got our collectible manager. I'm going to hit Control S and save so we can save the new scene. Now, where are we going to save this? Well, I'm going to go into scenes. I'm going to create a new folder, and I'm going to call this the managers folder. And then I'm going to hit save. Now, I'm going to add a script to this. It'll just be called collectiblemanager.gd. I'm going to hit create, and then I'm going to do nothing. I'm just going to hit Control S and save, and we'll come back to this specific script when we actually can. So let's go and set up a global signal. To do that, all we're going to have to do is, if we create another new folder here inside of our root folder, we're going to call this one auto loads. And then inside, we're going to create a new script. This one is just going to be called the signal bus. I'm going to hit create, and that creates us a new GD script. Now, what do we want to do with this script? Well, to make it so it actually functions the way we want it to, we're going to come up to project settings, auto load, and where it says path, set path or press add to create script. We're going to click the little folder icon, find the script we just created, which is the signal bus, hit open. Then you'll see here the node name, signal bus. We're going to click add, and that's it. We're done. What did this actually do? Well, autoloads are something specifically cool. They will always exist forever. They are kind of the singleton pattern. They will always exist. Now, the easiest way I can show this is you'll see here that the signal bus doesn't exist in our scene. But if I press play, and then I go over to the remote button here, you'll see that there's a new node for the signal bus. And then, of course, our entity and level container. This will always exist. Regardless of what scene we are on or where we're at, this signal bus will always exist. And that is perfect for us. Now, what do we actually want to do with the signal bus? Well, the signal bus is going to just be handling something specific, and that is globalized signals. We're going to be creating our own signals here. and they're going to be kind of doing certain things for us. So let's first create the signal. The signal, to create a signal, we're just going to write signal, and then we need to come up with a name for it. Well, I'm just going to call this on underscore collectible underscore collected. And then I'm going to give it parentheses. Now, this isn't a function, but to give it actual parameters, you need to give it parentheses. So I'm going to give it parentheses. I'm going to give it the name of value, and it's going to be the integer type, like so. Now, that is the signal created. Now, this is actually technically all you need to do for creating a signal bus and signals. You create the signal like this, and then you go and do whatever you want with them. I always like to go one step further because I like to have control over pretty much everything when it comes to the code that I create. So to do that, for every signal that we create, I'm also going to create a function for emitting that signal. So all I'm going to write is func emit underscore on underscore collectible underscore collected. Once again, I'm going to pass in the value, which is of type int, like that. Going to give it a void return type because it doesn't need to return anything. And that sets up the function. On the inside of that function, all we need to write is on collectible collected, so the signal itself, dot emit, and then inside the emit parentheses, we just want to pass through value. Now this seems like a whole lot of unnecessary work if all we really have to do is just use this. But in doing this, when we call this specific function to emit this signal, we'll be able to do a lot of other things. We'll be able to, if we really wanted to, we could make something specific happen just before or just after the signal emits as this function gets called. But we won't really be diving into that just yet. But on the plus side, this is our signal created. Now, let's go and put this to use. Let's go back to our collectible manager and the collectible manager script. Let's go into the ready function. So func underscore ready. Now inside here, we only have to type one thing, signal bus. So we want to access our signal bus by calling the signal bus. This is why autoloads are so useful. It allows us to actually call the script itself, which is the signal bus. And then we want to hit dot, and then we're going to want to kind of call the signal that we're actually wanting to connect to specifically. And that's what we're doing right now. We're connecting to a signal. So to do that, we need to write signal bus dot on collectible collected dot connect. And now it says that the connect function needs to have a callable. Now, I won't go too deep into detail about what callables are. What this is basically saying is, give me a function to run. Give me a function to run that has the correct parameters so I can do my thing. And we don't have a function in the script for that yet. So what I'm going to do is I'm going to ignore this for now and ignore that little red warning that it's giving me. I'm going to write func on underscore collectible underscore collected. It's of course going to need a value of type int because that's what we've just set up. No return type. And then for now, we're just going to write path. So we now have the onCollectable function set up within here. Now in the .connect part of this, inside of the parameter or inside of the parentheses, we're going to want to use double quotes for this. So this basically says, this is what I want to use. The double quotes are kind of necessary for this. So inside .connect, then we will do double quotes, and inside those double quotes, we'll just call on underscore. If you want to make it so you don't have any typos, you can just copy and paste the function you want to connect, and that's it. Okay, never mind, the double quotes aren't necessary. Well, either way, the onCollectable collected goes in here. Now we have this function set up. Now, what do we want to do with this? Well, what I'm going to do is at the very top here, I'm going to create a variable, and it's going to be for current underscore coins underscore collected. This is going to be of type int, and I'm going to set it equal to 0. And now all I have to do inside the onCollectable collected function is do current coins collected plus equals value. And this will set up our current coins collected. Now, once again, we don't actually have any coins, and this signal isn't actually getting emitted anywhere, so nothing is going to really function right now. Like, nothing's going to work. This isn't going to do anything. Hit Control S and save. And that is completely okay. We need to just go and create the coin now. So to do that, we're going to click new scene, other node, and now we need to figure out what type of scene route we want for this. You could just do a node 2D, or you could cut down on the amount of nodes you plan on using and just do an area 2D. Now, what is an area 2D? An area 2D is a region of space that detects other collision objects entering or exiting it. Our player entity has a collision object attached to it, so it can do things like move around the floor. So that's kind of what we're going to want to look for here. So let's hit create with area 2D. It's going to give us this little warning configuration. Move into 2D view so we can see a bit better. Little warning for the node configuration has no shape and it cannot collide. So we're just going to add a child. We're going to add a collision shape 2D because that's what it wants. And now we're going to want to figure out what the other things we want are, right? So we're obviously going to want to see something here. So let's go and add a new child to the collision or to the area 2D of sprite 2D. And then we'll go one step further and add an animation player as well. I will say one thing about the animation player. You've seen me add this to the player entity and now the coin or this specific thing that we're creating now. We will get to animations soon. They're going to be not really that complicated, but they do take a while to do sometimes. So we've got our sprite in the animation player. Let's go down into our assets, into the pixel platformer set that we have. Let's go look through all of our tiles and see what we have for coins. Because if I remember correctly, somewhere near the bottom here, there is a coin. There you go. Tile 0151 is the coin. We're going to put that in the sprite. I'm going to zoom in and make sure, yep, that is our coin. Now I'm going to move the sprite up a bit. So it's just hovering above the floor, and I'm going to move the collision shape up a little bit too, so it's centered on the coin. Now I'm going to go into the collision shape itself, and I'm going to give it the circle shape 2D. Now we're going to want this just a little bit bigger than the player, or a little bit bigger than the coin, sorry. That way it feels okay when we're picking it up. If it's too small, it just can feel a bit wrong, so just a little bit bigger like that is usually enough to work. I'm going to hit Control S and save. And we're going to save this inside the scenes folder under a new folder that we're going to call collectibles. What would help is if I renamed the area 2D to, we're going to call this base coin, because this is going to be the base for our coins. And there's a reason why I'm doing that. This will get into inheritance and some resource stuff that I plan on showing you soon. But for now, we'll just use base coin, we'll save it as base coin, and that's it. Control S to save, make sure it's saved, and now we're going to add a script to the base coin. Now, this is where things can get a bit interesting, because as I said, I want to use inheritance and stuff in the future. It means some of this stuff will get reworked, and that's fine. That's kind of a part of the game dev process, is you do end up reworking a lot of things as you go. Even with really good planning, you might figure out something doesn't work the way you want it to, or it doesn't interact with things how you want it to, so you end up reworking it. In this case, we're going to want a few things on this as just a basic start. We're going to want a variable for its value. It's going to be of type int. We'll set that equal to 1. We're going to need access to the ready function. And inside the ready function, we'll just write pass for now. We'll need access to the process function. Actually, we won't need access to the process function right now. We will, however, need to connect to a signal that the area 2D has. Now, there are a few ways of doing this with custom or non-custom, like actually built-in signals. And the first way of doing this is to go into node, have the coin highlighted, there we go into node, and you'll see here that under area 2D, there is the area entered, area exited, area shape entered, area shape exited, and kind of so on and so forth. Now, which one of these do we actually want to kind of use? Well, we could use area entered because the player technically has an area attached to it, but it doesn't have an area 2D attached to it. It does, however, have a body attached to it. Body is node 2D type specifically. And we can actually force that to check for a character body 2D, which will be even more useful. Now, there's a few ways of setting this up, as I said. We can double click on this, we can highlight the coin, it will create a receiver method for us, and we hit connect, and it will automatically connect it for us through kind of some behind the scenes engine stuff. or we can type out the connection. Now, personally, I prefer to type out the connection. Let me actually show you what this looks like. We'll do onBody entered, then we'll click connect, and there you go. It creates a function for us. You'll see here there is this little green arrow into a little window or door, and then same thing in the script. This is saying this signal is connected to this script. My eyes suck sometimes, so this is something I glance over quite frequently. So what I'll usually end up doing is I'm going to right click on that signal, I'm going to hit disconnect, wait for it to update in here, which it may or may not decide it wants to do. It does not want to do, so I'm going to hit Control X, delete that line, hit Control V, repaste that back in. And now we have the function for it, but we now need to once again connect to it. And I'm going to do that in the ready function. So to connect to it, we need to grab the body entered signal and use .connect. And we want to use the callable underscore on body entered. Now, I don't usually like to have underscores in front of my functions. There is a good reason on why you can do that for yourself, and that is known as privatizing things. Godot doesn't have a strict private public kind of functionality to it like some other engines and kind of coding languages do. But this basically just says this is private. Anything can touch it, but you know, just for the viewer basically to go, this is private. So I usually just tend to ignore that. Now we have our onBody entered. Now I can check if this is a character body 2D like this. So this will basically find any body that is a character body 2D. Now what do we want to do with this? We want to check if the body, and then we'll use dot, is underscore in underscore group. So what is this going to do? This is going to go, okay, if the body is actually inside of a group that we specify. Now, what groups do we have? Let's go into the player entity, and you'll see under node, next to the inspector, there is a groups function or a groups button. There is no group here. So I'm going to add one. I'm going to use a capital P, you call it player, there we go. I'm going to hit Control S and save to make sure that's saved. Go into base coin, and now inside of double quotes, we want to use a string name for it. And in this case, it will be player. And what do we want to do? So this is where I tend to do what's known as a null check. So instead of going if the body is in group, I'm going to go and check if the body is not in group. Because if it's not in the group, I want to hit return. Now what does that do? Well, doing it this way basically goes anything that walks over this coin that is of character body 2D type, if it's not in this group, do nothing. And it kind of stops it from running extra code if it needs to. And in this case, we don't want it to run any extra code, we just want it to return if it's not the player. If it is the player, however, which is where this code comes in afterwards, we want to do two things. We want to go into the signal bus, and then use .emit signal, or emit on collected or collectible collected. We want to pass in the value, because you know our function from signal bus requires a value of type int specifically, and then we're going to do something simple and queue free the coin. Now I'm going to hit Control S and save, and we should be pretty much ready to go. So what I'm going to do is I'm going to go back into main. I'm going to click on entity container, and then I'm going to hit Control Shift A to instantiate a child. We're going to instantiate the base coin. I'm going to move that to the right of our player a little bit, leave it about there, hit Control S to save. We're also going to need to make sure that inside of our manager container, we put our coin or collectible manager in there. We'll hit Control S again to save. Now I'm going to hit play, and we're going to see what happens. And there you go. The coin just disappears. Now, if I want to make sure that I'm kind of doing things correctly, because that didn't really give us much information, it did, however, say that the coin is disappearing because this thing entered the area. That's good. But how do we make sure that it's actually the player that it's looking for and it's not just kind of skipping this? Simply put, we can just remove the actual group itself. I go to player entity and I go and trash this group, and then I hit Control S and save, then hit play. We're going to go and see what happens if the non-player version walks over it. Literally nothing. So it's basically going, this is not the player. If I want to show this off even more, under the base coin in the script here, I can do a print statement. I can go print, this is not the player, and then we'll do one more time, print, this is the player. Now I'm going to hit Control S and save. I'm going to click play again, and we'll go and run over the coin, and we'll pay attention to the output down at the bottom right here, or bottom left. This is not the player. So it now knows that it's not the player. If I go back to the player and I add the correct group to it, which was with a capital P, hit Control S and save, hit play, go and run over the coin, it deletes it, and it says this is the player. Perfect. So what is this actually doing for us? Well, the collectible manager is actually storing the current value of all of the coins collected, which means this will slowly increment the more coins we kind of collect, right? To show that off a little bit more, I can grab the current coins collected, and then I can throw that inside of a print statement. Now I'm going to do what I did in the previous episode where I give it a string conversion. This is primarily just habit for me. I'm going to hit Control C and copy that, and I'm also going to throw it in the ready state, or the ready function here. So you should see this print 0. So let's see, we hit play, there you go, in the bottom here it prints 0. What happens after? It prints 1. So now we have this kind of permanent coin storage set up for us for any time we enter a level and we want to collect coins. And that pretty much handles a lot of the really simplified version of collectibles and collectible coins. Now, in the future, we'll be going through how to kind of adjust this, because we don't want to just have coins that only have value of 1. We might want 1, 5, 10, 20, 50, 100, 1,000, etc. And that's a lot of different coins. But how do we set that up to, or at least how do we change this to make sure it kind of manages and sets it up correctly for us? Well, we will get into that in a future part. For now, this is all we're going to be covering for the day. Next time we'll move probably into a little bit of animation stuff, and then more than likely some of the enemy stuff that we want to kind of cover and kind of get that up and running before we move into the upgrade systems and the kind of finalizing the game loop stuff for us. But for now, I hope you have a good day. I hope you enjoyed the video, and I hope you're having a great game dev journey, and I'll see you in the next video.